Yes, dear students, now there is again a very good question again, 13.5 of NCRT book. 13.5 of NCRT book. I'm explaining you this question because there is some problem in understanding the concept of mole. Students are very much confused about this mole concept. That's why I'm telling again here. Question is like this: a given coin has mass 3 gram. A given coin has mass 3 gram. 3 gram. Calculate the nuclear energy that would be required to separate the neutrons and protons from each other. For simplicity, assume that coin is entirely made of 29 Cu63. 29 Cu63 and M29 Cu63 given to be equal to 62.92960 U. So, what the question? Calculate the energy required to separate the protons and neutrons present in the mass of 3 gram of copper 63. 3 gram of copper. So I have explained you what is binding energy. So though I have told you that energy which is obtained from the mass defect is released by the neutron and nucleons to form the nucleus. And conversely, the energy required to break a nucleus and keep all neutrons separately at rest from each other is binding energy. So copper has 63 nucleon. Number of protons in one atom of Cu equal to 29. Neutrons equal to 63 minus 29 is equal to how much? 13 minus 9, 4, or 5 minus 2, 3. 34 neutron is a proton. So first of all you need binding energy of nucleus, and then totally required to separate the proton neutron in 3 gram. You need number of atoms in 3 gram. So that part here, atomic mass of copper is 63. So 63 gram of copper equal to 1 mole of copper of Cu equal to 6.023 10 to the power 23 atoms. Please try to understand. Though I have explained you that 63 gram of copper is equal to 1 gram atom mass of copper is equal to 1 mole of copper is equal to this atom. ये सीक्वेंस दिमाग में प्रेजेंस जरूरी है, and hence number of atoms in 3 gram of Cu is equal to 6.023 10 to the power 23 upon 63 into 3. Because 60 gram copper has this much atom, so 1 gram has this much and 3 gram this much. It is 21 here. So this number I have calculated for you. just for sake of simplicity, it comes out to be 2.686, 2.868 10 to the power 22 atoms हैं. तो number of atoms in 3 gram of copper, मैं इसको ऐसे लिखता हूँ, number of atoms in 3 gram of Cu is equal to 2.868 and about 22. इस क्वेश्चन पर ध्यान दीजिए, बहुत सिंपल क्वेश्चन है. प्रॉब्लम यहाँ यही है कि बच्चे नहीं समझते कि मोल कंसेप्ट क्या है. तो इट मीन्स यू वांट टू फाइंड आउट टोटल बाय ऑफ दिस नंबर ऑफ न्यूक्लियाई प्रेजेंट इन 3 ग्राम. तो यू नो कि बाइंडिंग एनर्जी अगेन B is equal to ZMH plus A minus ZMN or minus MZXA into 931.5. MeV. So what is that here? It is 29Cu63. So mass of 29 atoms, यानी कि 29 mH equal to 29 into 1.007825 and mass of 34 neutrons equal to 34 into 1.008665 U. When we multiply this, we get here it is to be equal to, I have calculated for you, you calculate your multiply, don't avoid. It comes 29.226925 and this come out to be 34.29461. So total this mass, therefore total mass of nucleon is equal to this sum, and it has come out here 63.521535. Just to save the time, I have solved it already in my copy, and hence mass defect, mass delta M 63.52135 minus mass of copper atom is 62.92960 and it comes out to be 0.59193 U. So binding energy of nucleus. So binding energy of 29Cu63 nucleus is equal to 0.59195 into 931.5, which comes out to be equal to, I have multiplied it here, 551.39 MeV. It means to separate nucleons of one copper nucleus, energy required 551.39, and therefore total energy required to separate nucleon of 3 gram of Cu63 is equal to, total number of atoms is this, 2.868 10 to the power 22 into 551.39 MeV. Now when we multiply all this thing, we get this total energy equal to, I will determine here, 1.58 10 to the power 25 MeV. Convert into joule, 1.58 10 to the power 25 into 1.6 10 to the power minus 13 joule. Why? Because 1 MeV is the joule. So by multiplication we get here 2.528 10 to the power 12 joule. This question has been asked in board exam 3 times in my teaching period. During my tenure as physics lecturer in a school, this question has been asked 3 times. Once in compartment exam, this question was there. So please try more questions from different books. I will be solving for competitive exam point of view many questions on binding energy curve and binding energy itself. But now I want to come to the new topic here, nuclear force. Very important topic for nuclear force. We have learned in last video that most of the volume of atom is empty. I have compared the nucleus with a tip of thumbpin and this room. If we assume the you see, we take a pin and we take the top of this. That much volume is occupied by nucleus, and the total volume of a room, big room like this, will be the volume occupied by nucleus. So nucleons are very tightly packed together. In spite, protons have positive charge, and you know Coulomb force is a strong force. I have explained many times that nuclear force, we compare the nuclear force between proton we compare the Coulomb force between proton and electron with their gravitational mass force, then we find it is 10 to the power 44 times bigger than gravitational force, Coulomb force. The protons have positive charge, they repel each other. But in spite of all such strong force, nucleons are held inside and many atoms are stable. So which force is that which provides such a large amount of binding energy? So that force can neither be gravitational nor basically electrical in nature nor magnetic. So people have defined a new separate force. So the force binding, the force which keep nucleon bound with each other in tiny nucleus is defined as a nuclear force. It's called nuclear force. Naturally, it is attractive force. Basically, nature, when binding the nucleon, though it becomes repulsive also, I will tell you later, nuclear force. It is a very strong and short range force. I have called it short range means it acts within the range of few Fermi, nearly less than 1 Fermi, close to 1 Fermi. It is strongly Fermi, 10 to the power minus 15 meter. I will discuss this short range force nature, which is also called a saturation protective nuclear force. This force cannot be gravitational force or electrostatic force. Coulomb force कहते हैं इसको, electric force or magnetic. It is another kind of force nuclear force. Therefore, is independent of mass and charge of nucleon. Nuclear force is therefore independent of mass and charge of nucleon, and therefore nuclear force between a pair of two protons is between two protons, comma, a pair of two neutrons and a pair of proton and neutron. Proton and neutron is the same. I hope you have got it. Force, nuclear force between a pair of two proton, two neutron and proton neutron is same because it is independent of mass and charge. It is short range force. If we plot the potential energy curve of two nucleons, potential energy of pair of nucleons. If we take two nucleons, distance in MeV, 1, 2, 3, 4 in distance are in Fermi, Fm. So the graph of potential energy curve come like this. It become maximum nearly at 0.8 Fermi. Potential energy is maximum, so the force of attraction is maximum when distance between two nucleons is 0.8 Fermi. And when distance between nucleon become less than 0.8 Fermi, it also start repelling each other. And at this distance, it becomes strongly repulsive also. Nuclear force, while holding the nucleon together, is attractive, but it is attractive within a small, within certain distance. After this distance, it becomes strongly repulsive. And due to this, protons and neutrons exist separately inside the nucleus. Otherwise, if it had been attractive always, then identity of proton neutrons separately had not been there. So we find proton neutrons inside nucleus because at distance less than 0.8 Fermi, it starts repelling and at certain distance becomes strongly repulsive. So nuclear force is also short range force. So energy is zero. So when distance between nucleon become more than 2 Fermi, it effect is negligible. That is why we say it is short range force. The nuclear force due to short range nature. Short range nature. Nuclear force has property of saturation. That is the force, that is nuclear force acts between immediate nucleons. Try to understand what I say. If it is a nucleus here, suppose these are nucleons present inside. They are tightly packed here. I am showing very much magnified view. If it is a nucleon here, it will be attracted by all these nucleons only, and it will be applying force of attraction on these nucleons only. This nucleus, these nucleons have magnetic force, but Coulomb force exists everywhere. So by nuclear force is short range force, but Coulomb force always there. So due to that, Coulomb force remain active, and nuclear force only in short range force. That is why the nuclei of bigger size are unstable. Coulomb force start dominating. Although here is force of attraction, इनके बीच में भी है, but nuclear force तो short range force act on immediate neighbor, but Coulomb force act on this also, this also, this also. So bigger nuclei are unstable. You can note it. I hope it is sufficient to explain. In paper generally question comes कि give 2 or 3 main characteristic of nuclear force, or sometime they ask write a brief note on nuclear force like that, or they may ask anything. And there is one more theory of nuclear force, Yukawa theory, that says that proton, neutron are not ultimate fundamental particle. They are further made up of pi mesons which keep on impinging. We can't have them separate. The pi mesons may be positive, negative, and neutral, and that way the nuclear force is spillover effect of Coulomb force of attraction, like that. You can find it in some book, not in NCERT. I hope you will enjoy this video. If you like it, please like and share and ask your friend to subscribe. Please, it will encourage me to do work further. My aim is only to work for those students who cannot reach a teacher. Thank you.